This is lesson 4.2, greatest common factor. The Venn diagram shows the prime factors of 12 and 18. Which factors are in the overlap section? What does this mean? The factors in the overlap section are 2 and 3. What that means is that they are factors of both 12 and 18. Is the product of 2 and 3 also a factor of 12 and 18? Yes, in fact it is, because 2 times 3 is 6, and 12 is 2 times 6, and 18 is 3 times 6. Make a Venn diagram showing the prime factors of 12 and 20. Identify the common factors and find their product. Well, from our above diagram, we know the prime factors of 12 are 2 times 2 times 3. Let's not put them in the Venn diagram just yet. 12 is 2 times 2 times 3. 20 is 2 times 2 times 5. So the Venn diagram would look like this. We would have 3 that's not a factor of 20, and 5 that's not a factor of 12, and we have the 2 and the 2 in the middle, which means 2 times 2 is 4, and 4 then is a common factor of both 12 and 20. As shown above, Venn diagrams use overlapping circles to show how common elements among sets of numbers or objects are related. They can also show common factors. The greatest of the common factors of 2 or more numbers is called the greatest common factor. There are 2 methods for finding greatest common factor. One is to simply list all the factors of the number. Notice that these factors are listed in order from least to greatest. That's crucial that you do it that way. This is very difficult for most students. A suggestion would be to make a factor tower if you insist on doing it this way. 1 times 18, 2 times 9, 3 times 6. Then if you list your factors from least to greatest, it looks something like that. Makes it a little easier. Still difficult for most students. 48 in this example would be very difficult. A better method is to use the prime factorization method. In this example, the prime factors of 18 are 2 times 3 times 3. 48 is 2 times 2 times 2 times 2 times 3. You can see that both have 2 as a common prime factor and 3 as a common prime factor. So the greatest common factor is the product of those common prime factors, or 2 times 3, which is 6. In my example, I'm going to use a slightly different method. It's based on the factor ladder method that we showed you in lesson 4.1. In this case, what I do is I divide both numbers by the smallest prime number I can find. In this case, it's 2. 8 divided by 2 is 4. 10 divided by 2 is 5. 4 and 5 have no common factors. So the greatest common factor of 8 and 10 is 2. B is a situation that occurs a lot. If a student has good number sense, they can see that I can divide 6 into 12 evenly and get a remainder of 0. So what that means is 6 is the greatest common factor of those 2 numbers. C is a unique situation somewhat in that 17 is a prime number. That means its only 2 factors are 1 and 17. Obviously, 10 doesn't have 17 as a factor, so the greatest common factor of these 2 numbers would be 1. When you're working with 3 numbers, clearly greatest common factor, best found with prime factorization. In this case, 12 is 2 times 2 times 3. 24 is 2 times 2 times 2 times 3. 60 is 2 times 2 times 3 times 5. All 3 have 2 as a common prime factor twice. All 3 have 3 as a common prime factor. So the greatest common factor of the 3 numbers is 2 times 2 times 3, which is 12. Now again, I'm going to use my factor tower method, if you want to call it that, or factor ladder method, which means I list the 3 numbers like this, and then I divide by the smallest common factor as many times as I can until I get a result in which all 3 numbers have no common factors. Now what I see here is 3 as a common factor. 3 goes into 30 10 times, 3 goes into 45 15 times, 3 goes into 75 25 times. I clearly recognize that those three numbers have 5 as a common factor. I divide by 5, I get 2, 3, and 5. 2, 3, and 5 are all prime numbers, so they have no common factors. Therefore, the greatest common factor of those three numbers would be the product of 3 and 5, which is 15. In my second example, I'm going to do the same thing. In this case, I see clearly that all three numbers are even, meaning they have 2 as a factor. 2 goes into 42 21 times, 70 35 times, and 84 42 times. Slightly more difficult, but most students would see at this point that all three numbers have 7 as a common factor. 3, 5, and 6 is the result I get from dividing all three numbers by 7. 3 and 5 are prime, have no common factors other than 1 with 6. So the greatest common factor of these three numbers would be 2 times 7, or 14. In this example, it says cheerleaders are making spirit ribbons. Blue ribbons come in a 24-inch spool, red in a 30-inch spool, and gold in a 36-inch spool. The cheerleaders want to cut strips of equal length and use the entire spool of each ribbon. What is the length of the longest piece of ribbon that can be cut from each spool? That's a really long way of saying find the greatest common factor of 24, 30, and 36. You can see that we've done prime factorization of all three numbers. All three have 2 as a common prime factor. All three numbers have 3 as a common prime factor. So the greatest common factor of those three numbers would be 2 times 3, or 6. Once you know that, then you can divide each of the, or add the total of the inches of ribbon on all three spools, which is 90. 90 divided by 6 is 15, which means I can make 15 spirit ribbons. In this example, Mr. Glover wants to make shelves for his garage using an 18-foot board and a 36-foot board. He will cut the boards to make shelves the same length. He wants to use all of both boards. Find the longest possible length of each shelf and how many shelves can he make. Well, again, a situation that's reasonably common. 18 goes into 36 twice with no remainder, meaning the greatest common factor of 18 and 36 is 18. 36 divided by 2 is, or 18 is 2. So I have 1, 2, 3 boards of 18 feet in length. The longest possible board then being obviously 18 feet. Find the greatest common factor of each set of numbers. Again, I'm going to use the factor ladder method. Here I'm going to divide both these numbers by 2. I get 9 and 15. I see that 9 and 15 have 3 as a common factor. I get 3 and 5. 3 and 5 are prime. Can't be factored. 2 times 3 is 6. That would be my greatest common factor. 45 and 60. I can clearly see that they have 5 as a common factor. Now in this case, that's not the smallest prime factor. It's just so obvious that I'm going to do it anyway. All I need to do is make sure I keep going. In this case, I still have 3 as a common factor. So even though I did them in reverse order, I get the correct answer. 3 times 5, my greatest common factor is 15. Example number 3, 20 and 50. Again, somewhat obvious if you have good number sense. 10 is the greatest common factor. 2 and 5 are prime. My greatest common factor would be 10. On to the next page to do the 3. 6, 8, and 12. Clearly 2 is a common factor. 3, 4, and 6. No common factors there. Greatest common factor of those three numbers is 2. 8, 20, and 40. 2 is a common factor. 4, 10, and 20. 2 is a common factor again. 2, 5, and 10. 2 and 5 are prime. No common factors with 10. The greatest common factor here then is 2 times 2, or 4. 18, 42, and 60. Again, 2 as a common factor. Should be easy for students to recognize. 9, 21, and 30 are my results. Those numbers have 3 as a common factor. 3, 7, and 10. 3 and 7 are prime. The only common factor they have with 10 is 1. So my greatest common factor here is 2 times 3, or 6. In my chart problem, it says, for exercise 7 and 8, use the following information. A store manager wants to display the inventory of 3 styles of bicycle helmets in rows with the same number of each style in each row. Find the greatest number of helmets that can be placed in each row. Well, again, long way of asking for greatest common factor of these 3 numbers. So I would find that out. These all have 3 as a common factor. 12, 24, and 15. I see 3 as a common factor again. I've got 4, 8, and 5. No common factors between those 3 other than 1. So my greatest common factor is 9. So the greatest number of helmets that can be placed in each row is 9. How many rows would I have then? 36 divided by 9 is 4. 72 divided by 9 is 8. And 45 divided by 9 is 5. So 9 rows in which there are 4 sport, 8 road, and 5 mountain helmets. Two vocabulary terms in this lesson: Venn diagram, which is a diagram that uses overlapping circles to show how elements among sets of numbers or objects are related. Greatest common factor is the greatest of the common factors of 2 or more numbers. These are both vocabulary that students should write in their notable and memorize for the vocabulary test that will be given at the end of the chapter. At this point, you should quit the video, go back to my Moodle page, log into Lesson Quiz 4.2, take that quiz.